Alright, so what we're doing today is just basically talking about matter. And matter, you might put this in your notes, is anything that has mass and takes up space. Okay? So it's anything that has mass and volume. If it doesn't have those two things, then it's not matter. So what's an example of something that's not matter? Probably the easiest thing would be something like heat. Anything that's energy itself is not matter, and heat's a good example of something with energy. So again, matter is anything that has mass and volume, and by volume we mean it takes up space. Alright? So there's really three states of matter, and these you should be familiar with: solids, liquids, and gases. And of these, a couple ways just to differentiate them: solids, liquids, and gases. The unit we are studying right now is going to be focusing on gases, so we're going to look at all three of them separately. But we might just first off just draw pictures. Alright, so if we just had, just think of these as cartoon bubbles, and our atoms or molecules are going to be represented by just spheres. Alright, so as we look at a solid, we might just have a bunch of spheres right next to each other. Okay, and they're going to be stacked on top of each other, something kind of like this. And kind of think of our little cartoon bubbles as gravity's coming down, so gravity is affecting this thing. And solids stay together, gravity doesn't necessarily affect them, it pushes them towards the bottom, but we're good. Okay, so as far as liquids go, we might have them all at the bottom. Okay, and if we could jiggle this thing back, they might flow up the sides a little bit, and they might flow up the sides over here as it goes back, but they're pretty much at the bottom. Alright, our solid's going to have very little space between each of these molecules, and our liquid's going to be pretty compact as well. Alright, and then our gases are going to be kind of just all over our little cartoon bubble. Alright, gravity's not necessarily affecting them that much. If we were to look at a huge cartoon bubble and look at the amount of gases at sea level compared to up on a mountain, we'd see that there's more at sea level because of gravity. But if we were just to look at a small sample of it, there would be equal separation between all of our molecules. Alright? And so a couple, like I said, differences is both of our solids and liquids are pretty close to being compact. And these are both known as condensed states of matter. Condensed states of matter. I was going to say SOM. Alright? And gases are non-condensed state of matter. Alright? Because they're so far apart they're not condensed next to each other, but there's lots of space between our gas particles. Alright? And you might put a little table, kind of a way to separate or talk about solids and liquids and gases, are to look at their volume and their shape. Alright? So I'm just going to put over here volume and shape. And we're just going to have three sections over here, a little table. Right? But solids have a definite volume. I'm just going to say it's definite. One way to get the volume of a solid, we might have a graduated cylinder, put some liquid in it, probably water, and look at the side and say, oh, this has 10 milliliters in it. If we put a solid in there, what's going to happen to the water level? It's going to go up because that solid is going to displace that water. Alright? So if it starts at 10 and goes to 40, we know that that solid takes up 30 milliliters of space. Okay? The other thing that's true about solids is they have a definite shape. Alright? Their shape doesn't change. We might be able to hit it with a hammer, maybe bend it a little bit, but without an outside force acting on it, solids have the same shape. Okay? Liquids, kind of similarly, have a definite volume. Right? We might have 10 milliliters of a liquid in a graduated cylinder. We might say, oh, that liquid is tall and it's skinny. But we can pour that into a beaker, and now it's not tall and skinny anymore. It's now short and fat. So it's the same amount or volume of liquid, but our shape is not definite anymore. So our shape is actually indefinite. Alright, and lastly, gases have indefinite volume. and indefinite shape. Alright? If we put a certain amount of gas into, if we put 10 milliliters of gas into a really big graduated cylinder and put some lid on the top, is that gas going to stay at the bottom? No, it's going to eventually spread out and take up that entire container. Is the amount of space between those molecules going to be greater? It will be, but gases take up whatever space container we put them in. Okay, so their volume gets as big or small as whatever they're in. Same thing with their shape. Gases don't have a definite shape. Whatever we put them in is the shape they take. Alright, so whatever container a gas in is the volume it has and the shape it has. The very last thing we're going to look at, as far as solid, liquids, and gases go, is just what do we call it as we go from one to the other. So I'm just going to put solid, liquid, and gas. Okay, and from a solid to a liquid, what do we call that phase change? A lot of you will know this. It is melting. Alright, and from a liquid to a gas, what is that known as? Typically we'll say boiling. A better kind of chemistry term is vaporization. So we vaporize things, but vaporization. And as we go from a gas to a liquid, this is why we get dew in the morning on the grass. That is known as condensation. And from a liquid to a solid is known as freezing. Freeze. Alright, and then lastly, two that you're probably less familiar with would be from a solid to a gas. Alright? And a solid to a gas is known as sublimation. There's not real good examples of this, but if you've seen dry ice, it's probably the easiest thing. A dry ice, piece of dry ice, it's really, really, really cold. It's frozen carbon dioxide gas, and that ice goes right into a gas. It doesn't melt. It goes right from solid to gas, and that's known as sublimation. Right, and lastly, our last one is from a gas to a solid. Right, and there's no real good examples of this, but this is known as deposition. Right, and kind of the way you think about this is the gas deposits itself as a solid. Okay, so deposition, and that is what you need to know about matter.